File photo of a previous Dragon rendezvousing with the International Space Station. Crs-13 arrived at the outpost in the early hours of December 17, 2017. Photo credit NASA just hours after Soyuz MS-07 and its three-person crew launched on a 2-day trek toward the International Space Station. SpaceX's Crs-13 Dragon, having launched days earlier atop a Falcon 9 rocket, rendezvoused with and was attached to the orbiting laboratory. Carrying more than 4,800 pounds (2,200 kilograms) of cargo, the capsule was installed to the Harmony module of the ISS at 8:26 a.m. S1326 GMT Dec. 17, 2017. This was the second time this particular Dragon pressure vessel made its way to the outpost. The hull is the same one used during the CRS-6 mission in the spring of 2015. Crs-13 began its trek at 10:35 a.m. Est 15:35 GMT Dec. 15, 2017, from Cape Canaveral Air Force Station's Space Launch Complex 40. Once it achieved orbit, it spent 2 days raising its orbit and catching up with the outpost. Crs-13 is attached to the International Space Station's Harmony module. Photo credit NASA TV. Using sensors and laser navigation, the capsule autonomously guided itself to close proximity with the station. The Expedition 54 crew monitored the final phase of the rendezvous and stood by to send the retreat a hold command in case any problems cropped up. However, the approach went by the book. Once the capsule was within about 33 feet 10 meters of the Earth-facing side of the Destiny Laboratory module, Expedition 54 crew members and NASA astronauts Mark Vande Hey and Joe Acaba used the robotic Canadarm2 to pluck the spacecraft from its free-flight drift. The capture was confirmed at 5:57 a.m. S10:57 GMT. According to NASA, the capsule contains various research experiments including an investigation that will demonstrate the benefits of manufacturing fiber optic filaments in a microgravity environment. The optical fiber production in microgravity investigation was designed by Made in Space and sponsored by the Center for the Advancement of Science in Space. The investigation will attempt to pull fiber optic wire from ZBLAN, a heavy metal fluoride glass commonly used to make fiber optic glass, reads a NASA blog post. Results from this investigation could lead to the production of higher-quality fiber optic products for use in space and on Earth. In the unpressurized section of the Dragon, its trunk is 1,422 pounds (645 kilograms) of external hardware. That includes a space debris sensor SDS that will be used to measure the orbital debris environment around the ISS for 2 or 3 years, according to NASA. The 10.8 square foot 1 square meter SDS will be mounted to the exterior of the station to provide near-real-time debris impact detection and recording. NASA says that the research could help lower the risks posed by space junk to both human life and critical hardware. Another item in Dragon's trunk is the Total and Spectral Solar Irradiance Sensor, or TSIS-1. The sensor is designed to measure the sun's energy input to Earth and will be 3 times more accurate than previous capabilities. According to NASA, TSIS-1 will enable scientists to study the sun's natural influence on Earth's ozone, atmospheric circulation, clouds, and ecosystems. Crs-13 is expected to remain attached at the outpost until mid-January 2018. After all its cargo is unloaded, it will be filled with more than 3,600 pounds (1,600 kilograms) of research, hardware, and crew supplies to be returned to Earth. After it is unbuoyed and released, the capsule will drift safely away from the ISS before performing a re-entry burn and splash zone in the Pacific Ocean, just off the coast of Baja California, to be recovered by SpaceX teams. Video courtesy of NASA. Tagged Crs-13 Dragon. Expedition 54 International Space Station. Laid stories. NASA. SpaceX. Derek Richardson has a degree in mass media, with an emphasis in contemporary journalism, from Washburn University in Topeka, Kansas. While at Washburn, he was the managing editor of the student-run newspaper, the Washburn Review. He also has a blog about the International Space Station, called Orbital Velocity. He met with members of the Spaceflight Insider team during the flight of a United Launch Alliance Atlas V551 rocket with the MUOS-4 satellite. Richardson joined our team shortly thereafter. His passion for space ignited when he watched Space Shuttle Discovery launch into space October 29, 1998. Today, this fervor has accelerated toward orbit and shows no signs of slowing down. After dabbling in math and engineering courses in college, he soon realized his true calling was communicating to others about space. Since joining Spaceflight Insider in 2015, Richardson has worked to increase the quality of our content, eventually becoming our managing editor at The Space Writer.